Okay, so what we're going to go ahead and look at today, there's one more set of identities that I need to go ahead and introduce to you, and then we'll, practice those for several days, make sure that you're okay with them. But a few things that are going on like this week and next week, I'm going to go ahead and take the extra notes, put them right here in Mondays in case you lose them, or in case someone who is watching this recording at home doesn't have them. We do have extra copies. But when we were talking about the happy minutes a few minutes ago, I said that we're going to do one every day this week except Wednesday. Why is that? Because I will not be here. Okay, I'll still be on campus, but I won't be in the classroom. I've got some interviews that I need to go ahead and take care of, so I'll have something left for you with the substitute. But the lesson that we start today, more than likely, even tomorrow, we're not going to finish it, so we'll probably take it into Thursday. Hopefully, we'll see by the end of the week if we can start the next unit, which is solving trig equations. If we can't, I mean, that's fine. We'll go ahead and start that next week. There's definitely no rush, okay, when it comes to this class. I think we're doing really well. Served us well over the school year so far. But don't forget your homework is due tomorrow. The 10-question worksheet over sum and differences that we started last week. On Friday, that's when we're going to have our first official quiz of the 6 weeks, and it's going to be over sum and difference identities. So really, these happy minutes right here, where you have to expand them or condense them and evaluate, that's basically what's on your quiz. So I thought, these happy minutes this week not only would hopefully give us some good grades, but also give us a little more practice and preparation for what's coming up on Friday. Okay, the only other thing I need to mention, well, actually two things, I'm sorry. 2 weeks from today, I know we're still a little ways out, but on Monday the 4th, the last Monday prior to spring break, we're going to have our first exam. So we'll look for it to have the sum and difference identities, the double angle identities, maybe a equation or two. We'll kind of see how far we get with that. I'm kind of doubting the equations at this point. The only other thing, several of you probably saw me walking around the cafeteria this morning. So I was told on Friday that my duty this week is to do that. And unfortunately, it's from 7:45 to 8:05 the bell, so there won't be any morning tutorials this week. If you do have a question, if you need to catch me, I'll be walking around, the cafeteria looking super happy because that's really what I would rather be doing, right? That's exactly where I want to be. But yeah, just, come talk to me. Or if you need to, just swing by right after school. I'll see if I can help you out real quick. But I do apologize about that. Did most people get my remind text last night? Okay, good. So if you do forget, there's also going to be a sign on the door. And like I said, I'll be in the main dining hall all this week. I think that's everything I've got, unless anybody has any questions about what's going to be happening this week, coming up, getting ready for spring break, anything like that. Spring break, actually, your last day is going to be 2 weeks from this Friday. So 3 school weeks, and then you guys are off a week. And then after spring break, yeah, we're in testing season. Things are going to start going a lot faster. Mhm. There you go. Think about it. We're getting down to just a handful of months. You guys are going to be walking across the stage, getting that diploma, moving on to your next part of your life. So, not ready to leave me, Mr. Not ready to leave me. Well, let's see. How many years have I taught you? You taught me for 2 years. 2 years? Because algebra 2, right? And then in pre-cal. Okay. So 2 years. Some people were unlucky enough to have me for 3 years. So I know, good God. I don't want to listen to me for 3 years. So anyway. Okay.
When I leave, I'm just going to sit there and listen to the recordings on loop.
I imagine a lot of people would do that because they get out, into the summer and they're like, man, where are my jokes? And you start having withdrawals and you start shaking, lashing out at family and friends. There you go. Just listen to me on the summer, yeah. All right, so let's go ahead and start the double angle identities. These are identified by sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Now, they're actually found very easy if you go ahead and use the sum identities from the section we were just looking at. So let me show you what the identity is for sine of 2 theta. So we're going to go ahead and derive each of these, and they're very, very simple derivations. Even these right here, they're considered proofs. Okay, so if I have sine of 2 theta, all I'm doing is doubling the angle measure that we have, right? 2 times it. And it doesn't matter if it's alpha or beta or even 2x. Does not matter. Well, sine of 2 theta, is that the same as saying sine of theta plus theta? Would theta plus theta still give me 2 theta? Yeah. Okay, it doesn't matter what the variable is. That's going to be true. So now, think of this first one as alpha, and this second one is beta. Now just expand it, very similar to what we just did on our happy minutes. Now remember, sine wants to keep the plus, but also sine wants to alternate when we multiply. So I'm going to say sine of alpha times cosine beta. Okay, I'm going to keep the plus. Then we have cosine alpha sine beta. But you'll notice every time alpha and beta are just the same variable. Okay. So do you notice anything? It is, but what do we notice about the two terms that I ended up with? Sine times cosine, cosine times sine. They're what? They're not reciprocals. Could I rewrite cosine times sine? Could I say sine of theta, cosine of theta, plus, just flip them. Sine of theta, cosine of theta. Yeah, you'll notice they are what kind of terms? Ooh, they are, starts with the L. Like terms. There we go. See, they both have sine theta, cosine theta, so all I have to do is combine their coefficients. So what's 1 sine of theta, cosine theta, plus 1 sine of theta, cosine theta? 2 sine of theta, cosine theta. That is now one of our new identities. When we see sine of 2 theta, we can expand it as 2 sine theta, cosine theta. Or if I see a 2 sine theta, cosine theta, we could rewrite it as sine of 2 theta. Remember the rules, those identities are still reversible. Okay. And that's how we're going to go ahead and show all of these. We're going to go ahead and use the sum identity for each of them. So next up would be the double angle identities for cosine. So I'm going to do it the exact same way. Cosine of 2 theta, okay, that's the same as saying cosine of theta plus theta. Just like we did before, because theta plus theta is 2 theta, right? Okay. Well, now, how would I expand this using these alpha and beta? The only thing is that alpha and beta are now exactly the same here. Okay. So it'd be cosine theta, cosine theta. Because remember, it goes cosine alpha, cosine beta, and then what? You're right, but what happens to this? Minus. Remember, cosine wants to change the operation. So the adding goes to minus, and then it would be sine of alpha, which is theta, times sine of beta, which is also theta. Okay. Now this one, what's cosine theta times cosine theta? Okay. Now, would theta be squared or would the cosine be squared? There we go. So this would be cosine squared of theta minus, that would be sine squared of theta. Okay. There you go. So every time you see cosine of 2 theta, this is his identity. But he's kind of unusual. He is the only identity out of every one of them that we're going to be looking at that actually has 3 different versions. Okay, so I'm not going to worry about showing you the proofs for the other 2. If you want me to, I can absolutely go ahead and do that. But this is also equal to, okay, 2 cosine squared of theta minus 1. That's also an identity. And it also equals 1 minus sine squared of theta. Oh, sorry, I'm 2. 1 minus 2 sine squared of theta. Okay. Actually, it's using the Pythagorean identity is how we would have proven those. There you go. So here's the thing. Every time you see cosine of 2 theta, you actually have a choice. You could use any of these 3, especially when you're evaluating a problem such as I'm about to show you. Does not matter which one you use. Okay? It will always give you the same answer. So really it's your choice. Whichever you feel is going to be the most beneficial, the easiest for you to deal with. Now he's the only one that has 3. Okay? And then we come down here to our last one. Okay? We're not going to be looking at double angle identities for, say, cosecant and secant and those. You could simply just take the reciprocal of what we have here if you really needed to. But I won't give you any problems that involve those. Okay. So now I have tangent of 2 theta. Well, let's see. For sine of 2 theta, I started sine of theta plus theta. Cosine of 2 theta, I started cosine of theta plus theta. So how am I going to start here? Tangent of what? Plus theta. There you go. We start out these proofs every time the same way. Okay, so again, we're taking the sum identity for tangent, but alpha and beta are the exact same value, whatever that happens to be. Okay, so let's think about what was the sum identity. It was the only one that went fractional. Okay, plus, there you go. So what we're going to have here, remember it was tangent of alpha plus tangent of beta. Tangent always kept the operation on top the same, but below is where we subtracted it. Then we have 1 minus, there you go. So tangent of alpha, theta, times tangent of beta, which is theta. Okay. Well, do you notice anything? What can you do up top in the numerator? What's tangent of theta plus tangent of theta? That's 2 tangent of theta. Yeah, we're just adding like terms. So 2 tangent of theta over. Is there anything I can simplify down below?
You could times that, you could tangent squared theta.
There you go. Tangent times tangent is tangent squared. So 1 minus, bless you, tangent squared of theta. So whenever you see tangent of 2 theta, bless you, there's his identity. See, I feel bad. Now everyone's looking at you. Looking at you. Ah, get it? Okay. All right, but those are our new identities. And in fact, after the long, long list of identities we've gone through for a while now, no more new identities after this. That's all we got. Okay? That's the end of the road when it comes to the identities. You could, absolutely, yes. And there's also other ways you could do this, like if you're verifying or if you're trying to simplify expressions. If you had tangent of 2 theta, well, you remember by your ratio, your quotient identity, tangent equals sine over cosine, right? So tangent of 2 theta would be sine of 2 theta over cosine of 2 theta. So all of those previous identities, yeah, they're still going to hold true. You're going to still use those as well. Okay. So now there is a problem on your packet. Okay, but let's go ahead and do this one first. So this one's not on your packet. So if you just want to follow along or if you want to write this maybe on the back, completely up to you. Okay. Right, Lilybell? This is not on your packet. I just want to go ahead and do an extra problem. Okay. Right, Lilybell? Right, Lilybell? Right, Lilybell? There we go. All right. Okay. So given this triangle, I want to go ahead and find the value of each of these 3. Okay. Now, let's see here. We have a triangle where the legs are 1 and 4 units long. Okay. How are we going to figure out the hypotenuse? Okay, Pythagorean. Okay, so let's say this is my radius, like we always do r. So that would be 1 squared plus 4 squared is equal to r squared. So that's 1 plus what? Oh, 16, there we go, is equal to r squared. So 17 is equal to r squared. Now how do I get r? There we go. So this is the square root of 17. Now, I always think it's a good idea from those identities, you're going to need sine of theta, cosine of theta, and tangent of theta. So why don't we go ahead and find those? Here's theta. What would the ratio sine of theta be? Remember, this is opposite over,
So you could just do pi. My bad. Oh.
so just the y value over the radius, but here the radius isn't 1.
So 1 over the square root of 17.
There you go. So it'd have to be 1 over the square root of 17. Now, there's something here. For these problems, you actually don't have to rationalize if you don't want to. But it is completely up to you. Do you want to rationalize or leave it as is? You do want to rationalize? Okay. So what would that be?
Just 17 over the square root of 17.
Ooh.
Or 17 over square root of 17 over 7.
Square root of 17 over 17. There we go. Okay. Is everybody okay? We'd have to multiply both parts by square root of 17. So now I want cosine of theta. Well, let's see. That's x over r. So 4 over the square root of 17. And what would that be if I rationalized it?
4 to the square root of 4 times square root of 17 over 17.
Okay, so 4 square root of 17 over 17. That's a 17. There we go. And then we got one more to go. Tangent of theta. This is just the normal right triangle trick. Tangent of theta. Yeah, that's opposite over adjacent. 1/4. Nothing to simplify there. Okay. Now, you remember how we looked at the sum and difference identities as formulas? Once we expanded them, then we just substituted in the correct fraction. Well, we're going to do the exact same thing here. Those three forms that we were looking at, sine 2 theta, cosine 2 theta, tangent 2 theta, each one equals its own formula. So all we have to do is plug in. Remember, sine of 2 theta, that was 2 times the sine of theta, cosine of theta. That's what we just came up with. Okay. Cosine of 2 theta, remember, there were 3 possibilities. We could say cosine squared minus sine squared. We could say 2 cosine squared minus 1. Or what was that third one? 1 minus 2 sine squared of theta. They all equal the same thing. So it is always your choice, whichever one of those 3 for cosine 2 theta you want to use. And I'll prove that to you in just a second. And then for tangent of 2 theta, we just got 2 tangent of theta divided by 1 minus tangent squared of theta. Okay. So these are the new identities that I'm introducing to you today. Okay. So if I want to know sine of 2 theta, well, all I'm going to do is plug in those ratios. See, I've got the 2. Okay. You told me that sine of theta, we found that to be what? Square root of 17 over 17 times, what'd you tell me cosine of theta was? 4 times the square root of 17 over 17, right? See, it's just like the sum and difference. You're just substituting in the correct ratio. And now I just want to simplify that. Okay. All right. But I'm going to go ahead and show you something here, especially because you guys wanted to go ahead and rationalize. How do we multiply fractions? I keep forgetting. Oh, now we only need a common denominator if we're going to add or subtract. So we just multiply straight across, right? So I want to multiply 2 times the square root of 17 times 4 times the square root of 17 all over 17 times 17. Now, the reason I just waited on this one, well, what's the square root of 17 times the square root of 17? Wouldn't that just be 17? Okay. And 2 times 4 would give me what? So 8 times 17 over 17 times 17. See, instead of just multiplying all this together and getting really big numbers, yeah, just go ahead and cross out a couple of 17s. Even if you did multiply those big numbers, would it still simplify to 8 17ths? That's it. That is sine of 2 theta. It's just another couple of formulas like we've been dealing with. And do we have to memorize these? No. You can use your notes. I mean, if you want to memorize them. Okay. I encourage it, but I'm not going to hold you to it. That's all you do. Look at it as a formula. You just plug in the right ratio, the right fraction. Okay. So now let's determine cosine of 2 theta. So the only thing here is you got 3 choices, but any of those 3 will always give you the same answer. Brandon, what do you like? Okay, so you want to do the 1 minus 2 sine squared? Okay. So let's use this one. Okay. 1 minus 2 sine squared of theta. Okay. So I've got the 1 minus 2. Now, sine of theta, from the triangle, we got that to be square root of 17 over 17, right? So I'm just going to plug him in. But there's something I'm forgetting. The square. See, whatever I do to sine, if he's squared, then I want to make sure to square that fraction that I plug in. So I chose a formula, I just plug in the right fraction. And then from here, the algebra takes over. Okay. So let's see here. So that's going to be 1 minus 2. So that would be the square, just 17 over, why don't we go ahead and say 17 squared? Okay. I mean, what is 17 squared? 200 and, ooh, a little low. Ooh, a little higher, a little higher. 289. There we go. Did I say that? Oh, I'm sorry. It's a Monday. Hey, I knew 17 squared was 289. Yay. Hey, what are you going to do? My hat's too tight. There it is. Oh. Yep. Okay. There you go. It's been a rough weekend, too. You know, my sister picked up both of my kids from school on Friday. And she decides to take them to the park for a little bit. And I'm like, hey, that's great. You know, take them to the park, let them run around, burn off some of that energy, you know, so they'll be tired that night and they won't be running around the house. Well, I'm at home when my sister shows up with my kids and they walk in with a dog. My little girl is 6 years old, and while they were at the park, this little Chihuahua comes running up. And she's like, oh my God, he's so cute. He's got to have an owner. We have to take him home and try to help find the owner. So, of course, my aunt said, yeah, let's do that. So she brought the dog home. Luckily, so we kept the dog the entire weekend. But we took the dog to the vet on Saturday to see if it had a chip in it, and it did. So I'm like, all right, we're going to get this dog back to his owner. Well, it's a service called PetLink. It's some kind of app, so we don't actually get the information. We know the dog's name is Snoopy, but we don't have any information about the people. What we do is on the app, we provide our phone number so that people can contact us, and the site will contact them and say, hey, your dog was found, and this is the number you need to contact. So the owners have not gotten back to us yet. We still have the dog. So what my wife and I started talking last night, because we still haven't heard anything from these people, and we use the app again, we're like, at what point do we go ahead and make a decision about this dog? Because he's a very good dog. He's housebroken, hasn't been in an accident yet. I'm not making a case to keep the dog because I don't want to keep the dog. We've already got 2 big dogs, and I don't want to step on this tiny little dog. But I've got a border collie and a beagle. So they're much larger than this Chihuahua. Luckily, they're all getting along very fine. You know, the cats don't like him too much, but cats are jerks. Yeah. Mm-hmm. What's that? I'll take a picture of him tonight. So hopefully in the next day or so, yeah. Anyways. Yeah. Yes. I'm hopefully talking to my wife tonight because we don't know how long to wait. Because we're thinking, you know, the people went to all the trouble of having the dog chipped. And
you get chips done for free though.
Can you?
Yeah.
You don't have to pay for those?
No, it's like City of Lubbock was like
Really?
Like if you adopted one of the animals, it was for like $50.
Well, I'm hoping that these people aren't getting our information and going, we don't want that dog anymore, you know, because we don't know what to do with it. So, anyways. Okay, so is everybody okay how I went from here to here? The square root of 17 squared is just 17 and 17 squared. But again, the reason I left it like this, you could just say 1 minus 2 times 17 over 17 times 17 and go ahead and, cross out a couple of those. Okay. So this is really 1 minus 2 17ths. Is everybody okay with that? Okay. Well, now, you need a common denominator, which is what? 17. So would everybody agree that 1 is just 17 17ths? Okay. So what is 17 17ths minus 2 17ths? 15 17ths. And that right there is cosine of 2 theta. Okay. Now here's the thing. Okay, Brandon said, I want to go ahead and use the 1 minus 2 sine squared of theta. If we had used either of the other two, would we have still gotten 15 17ths? Yes. The formula you decide to use makes no difference for cosine of 2 theta. Okay. Now, here's our last one. Tangent of 2 theta. Okay, so here's the thing. What was tangent of theta? It was 1/4, right? So again, I just plugged that fraction in for tangent of theta. So tangent of 2, there were 2 tangent of theta is 2 times 1/4 over 1 minus tangent squared, so that'd be 1 minus 1/4 squared. And see, now it's just a matter of simplifying, right? But there's actually a shortcut here. On these problems, if you're asked to find all three, sine of 2 theta, cosine 2 theta, and tangent of 2 theta, you actually don't have to use the formula on the last one if you don't want to. That's exactly right. Remember, we said before that tangent of 2 theta is sine of 2 theta over cosine of 2 theta. So you could simply take your answers, divide those, and not have to do any algebra at all. Because what did we get for sine of 2 theta? We got 8 17ths. So I'm going to divide that by cosine of 2 theta, where we got 15 17ths. And what do we do when we divide by a fraction? We multiply by the reciprocal. So this would be 8 17ths times 17 15ths. And you'll notice what happens. So it's just 8 over 15. Now, had we continued, that's a 15 right there. Had we continued to use this formula, would that have given me 8 15ths? Yeah, absolutely. Okay. But if you don't feel like going through that algebra, there's that little shortcut right there, as long as you have sine of 2 theta and cosine of 2 theta. Okay. How are we doing? Okay? Any questions? Any problems? Okay, we'll go ahead and do another one of these tomorrow. We'll also have another happy minutes. So let's stop there. Okay, very cool.